Alright, in this video I would like to talk about data frames. This data structure is probably the one you're going to use the most when you analyze the data using data mining algorithms. Alright, so if you know SQL, this is very similar to table in SQL. Of course, it's actually different, but it's kind of similar to a table. Okay, so let's take a look. And to create a data frame, well, what else? You need a data frame function. So as usual, if you know more about data frame, just go to a console area and type data frame after question mark, and then you're going to have all the details about data frames. Okay. Alright, so let's create a data frame. First, let's create a vectors. So you can think the data frame as a list of vectors. So we talked about vectors, also we talked about list. So data frame is actually a list of vectors. So let's create the vectors of employee ID, last name, first name, salary, and department number. Okay. So we have the employee ID vector, and the last name vector, and the first name vector, and the salary vector, and department number vector. Okay, and once those vectors are created, we can actually combine them using data frame function. So data frame and those the vector names: employee ID, L name, F name, salary, and department number. So now we have employee employee data frame. So it's going to look like this. So we have employee ID 101, 102 all the way to 107. We have 5 columns: employee ID, L name, F name, salary, and department number. Sort of what looks like a table in SQL, right? All right. So let's look at the what kind of data type the employee is. It should be data frame. So data frame, right? Okay, and also we can check the column names of employee data frame. Okay, so we have employee ID, L name, F name, salary, and department number. So let's take a look at the one of those vectors, employee $, L name. Okay, I think we talked about that. In most of languages, they use a dot or period, but in R they use a $, to show the column of a certain data structure. In this case, data frame. Okay, so here we have employee $, L name, so we can have all the data about last names: Johnson, Smith, Wang, and so on. So if you look at a data type, what else? It's a vector, but actually it's a factor. So what happens is when they see the character data, when you use a data frame, the default is they actually define that as a factor rather than a character vector. So if you want to change it from a factor to a character vector, what you have to do is you can have s.character function to change the factor to the character vector. Okay, so let's change the factor to a character vector. Okay, and let's take a look. So now the L name, the last name column, is now defined as a character vector. Okay, so as you can see over here, the data.frame function, the default is they use factors for the characters. So if you want to have a character factor, a character vector, you can actually define it. When you define it, you can set the strings as factor as false. Okay, so let's do that. So if you do that, and all these last names and the first names all defined as a character vector, all right, instead of a factor. man, a vector and a factor, they're kind of difficult to pronounce. Anyhow, also now we can count the number of rows and the number of columns. Okay, so n row, number of rows, employee, there are 7 of them, number of columns, there are 5 of them. Or we can actually get those two numbers by using dim function, like a dimension function. So 7 and 5, 7 rows and 5 rows. I'm sorry, 7 rows and 5 columns. Okay. And if you want to see the column names, also you can use col names, COL, column names of employee, and then we can have emp ID, L name, F name, salary, and department number. Okay. Also, you can kind of review the data. When you have a huge number of data frames, it's going to be very difficult to get some idea by showing all the data. So you can use a head or tail functions to see some of the data. So head data shows you the first 6 rows. Okay, the default is 6. Okay, but if you want to see only 3, then you can actually set the parameter 3. Okay, tail function shows the last 6 columns. I'm sorry, last 6 rows. Okay, if you want to see something else like a 3, last 3 rows, then you can use tail with a parameter value of 3. Okay, so let's take a look. Alright, so if you don't do anything, then they show you 6 rows. Okay, but if you set the number of rows to 3, and then they show you only 3. Or you can see the last 6 rows. Okay, so like this, as you can see over here, so 102 all the way to 107. Okay, the bottom 6. Okay, or you can just see the last 3. Okay, so 765. All right. All right. So now let's try to retrieve some subset of columns or rows. This is actually very similar to restriction or projection operations in SQL. Okay, so we can have a horizontal subset or vertical subset, or we can have a combination of a horizontal and a vertical subset of a data frame. Okay, so let's take a look. And the first what you can do is you can just specify the column name, and then you can get only the subset of this in this case a vertical subset of that data frame. So if you do that, you can have emp ID 101 all the way to 107, or you can actually have both 2 of them, like emp ID and last name. Then you can have you can project those 2 columns. Okay. Or instead of those column names, you can also use a location of the columns. So this one shows, give me the first and the second column. Okay, remember C is a combined function for vector. So 1 and 2 give me the first and second column of employee data frame. Can you see that? ID and the L name. So this is basically the same as C emp ID and L name. Okay. So in this case, we used column names. In this case, we use the location. Okay. Also, we can get a multiple columns using a colon. So 1 colon 3. So this means 1, 2, 3. Okay. Give me the first, second, third column of the employee data frame. Okay. So we have emp ID, L name, and F name. One thing interesting about R is this using a negative number. In SQL, we don't have anything like that, but this is actually very convenient, very handy actually. So I kind of like it. So employee -2. This means show all those columns except the second one. Show all the columns except the second one. It's kind of interesting. Okay. So you can have, so you can see all the columns except the last name. Okay, so this is actually very convenient. Okay, let's take a look at how you get a subset of data. by specifying the index values for rows and columns. Okay. All right. So to do that, what you have to do is we can specify the index values for rows or columns. Okay. If you don't specify anything, that means everything. Okay. So employee 2 comma nothing. So that means give me the second row. Okay. So let's take a look. So we have a 102 Smith Nancy all the way to 100. Or we can have give me the third one. That is 103 when actually 110,000 and 200. Or we can use a colon to retrieve multiple values. So this means what? 1 through 3. So first one, second, and the third one. Okay. So 101, 102, 103. Or you can also retrieve columns. Retrieve rows by specifying the vector. So this means the vector of 1, 3, 5. So give me the first one, third one, and the fifth one. Okay. So as you can see over here, 101, 103, and 105. Just like we talked about over here, this is all very interesting. You don't have this kind of thing in SQL. So what this means is, show me all the rows except the second one. See, -2. Show me all the employees except the second row. Okay. So we have a 101. See, 102 is missing, 103, 104, and so on. Also, we can say, hey, show me everything except second and the third one. Okay. So 101, 102, and 103 not there because we said do not show second and the third one. Okay. Also, we can have multiple rows by using a colon. So this means what? Don't show 2, 3, 4, 5. Okay. So we have 101 and 2, 3, 4, 5 are not there. And then now we have 6 and 106 and 107. Same thing over here. Instead of a -2 to -5, we can say -5 to -2. Same thing. Okay. Also, we can use a vector. So show me everything except the first, third, and the fifth row. Okay. So we don't have a 101, 103, and 105. All right. So not too bad. Also, we can have a subset of columns by specifying the column indexes. Okay, so this one without any specification, any indexes for the row, that means everything. Okay, so this means, hey, show me only the first and the second column. Okay, show me only the first and second column. Those are employee ID and the last name. Also, we can show multiple columns using a colon. 1:3, that means 1, 2, 3. Okay, so emp ID, L name, and F name. So this one is show me everything except the second column. Okay, so L name or last name is not there, and everything else is there. Okay. Also, you can have a subset of columns and rows by specifying the indexes for both rows and the columns. Okay. So this one shows what? Show me the first row and the first column. So that is 101. So first row and the first column. Or we can say, show me the 3 columns, 1, 2, 3. I'm sorry, 3 rows, 1, 2, 3. 3 rows and 4 columns, 1, 2, 3, 4. So we have 101, 102, 103, 3 rows and 4 columns. First 4 columns. Emp ID, L name, F name, and salary. Okay. Right. Also, we can get the subset by actually specifying the value of a certain column. So in this case, show me 3 columns, first 3 columns, 1 through 3, so 1, 2, 3, only if emp ID is 102. So 102 Smith and Nancy. So concept is actually very similar to SQL. SQL's restriction and the projection operation. Also, we can retrieve the data by specifying the logical operations. Okay, so how about this one? So show me only if employee ID is 101. Okay, so everything about 101, 101 Johnson and stuff. Or the last name is Smith. Show me only if the last name is Smith. As you may remember, the equality comparison in R is two equality signs, equal and equal. Okay, so only if last name is Smith, and then show that particular row. So 102 Smith, Nancy, 95,000 and 100. Okay, the next one says, hey, show me all employees only if his or her salary is at least 130,000. Okay, so show all the employees only if his or her salary is at least 130,000. Okay, so as you can see over here, 105, 130,000, 107, and 140,000. Okay, how about this? Okay, show me all the employees only if department number is 100. Okay, so like that. Okay, or also you can say, hey, when you have multiple conditions, you can connect them using AND or operation. And for an AND operation to be true, both conditions have to be true. Okay, remember that. For an AND operation to be true, both conditions have to be true. For an or operation, or for an or operation to be true, then at least one condition has to be true. Okay, so let's take a look. So show me all the employees only if salary is at least 110,000 and ampersand sign and, so this is an and, department number is same as 100. Okay, so for an AND operation to be true, and each employee has to satisfy both conditions. Okay, alright, so there's only one. So department number is 100 and this person making 125,000. So this first condition is true and the second condition is true. So 106 is the one. Okay, or you can say or operation. Again, for an or operation to be true, at least one condition has to be true. So show me all the employees only if the salary is at least 110,000 or department number is not 100. Okay, so equality comparison is two equalities, equal signs. In case of not equal, that means exclamation mark and an equal sign. Okay, so let's take a look. So show me all the employees if the salary is at least 110,000 or department number is 100. So department number 100, 106, no problem. Or at least the salary has to be at least 110,000. So 103, 104, 5, 6, 7, these satisfy these or conditions. Okay, or you can say, hey, show me everybody if the department number is not 100. Okay, so everybody who is working for 200, 300, or any department but 100. Okay, or you can also use a not operation. So this one says what? Show me every employee. Show me all employees if the department number is not 100. Okay, so instead of a not equal sign, we basically negate the logical value of this condition. Okay, so 103, 4, 5, 6. So they're working for 2, 3, 4, and 200. Okay. Of course, we can specify both rows and columns. Okay. So for this one, show me first, second, and the third columns only if MPID is 101. Okay. So like this, 101, Johnson and Steve. And this one says, show me the first, second, third, and fifth columns, only if the last name is a Smith. Like this, so 102, Smith, Nancy, and 100. Alright?